Hi, everyone. On behalf of the organizing committee of this year's Distributed ML workshop, welcome to our workshop. So we are very grateful to all the people who participate in the programming committee, without whose help this program won't actually be possible at all. So I think everyone here in the last decade have witnessed the rapid progress of machine learning and its application to many things that related to our daily life, from smaller things like sensor automation to even larger scale collaborative environment like smart city, right? Behind all of these amazing applications is the foundational system architecture about distributed training. If you look at the improvement of like increasing requirement of computational capacity over the years, we see over the last decade this rapid exponential growth of how long it would take to train a single machine learning model on a single device, measured by how many flops that you need to train such a model. So model training becoming more and more expensive. And on the other hand, we should all be lucky to have the figure that look like this. This is the data that we get from MLPerf 1.1 training ResNet. As we can see, the x-axis is the number of accelerators are using, and the y-axis is the runtime. Well, we have this exponential increase of requirement on computation. On the other hand, we also have this amazing scaling curve. So I think it's fair to say that the exponential growth of model over the last decade is largely fueled or enabled by the scaling that we can do in distributed system. So if you look at this amazing scaling curve, it's really the joint effort between many communities, because to enable such a huge number of scaling, right, you also really need to co-design the algorithms, the hardwares, and systems. And it won't be possible without the collaboration between computer architecture, machine learning, and system community all together over the last decade. So I think today, it is the time that we should celebrate the success of distributed learning in the last decade. But also, as we will see in this workshop, there are also many challenges and opportunities that we have today that require even more collaborative effort in solving them. Scaling and performance is not the only factor for distributed learning. When machine learning starts to have more and more impact on our daily life, there's also the requirement to really understand its social impact. Instead of only focus on the quality or the performance or the speed, there's also the increasing demand for machine learning to be trustworthy. And people start to have the demand for privacy, for security, for robustness, which is a great thing. And this is decoupled with the distributed learning infrastructure, where all the data could be hosted by different data shareholders, and each one of them have their privacy, security, and robustness requirement. Putting this together, there's also another very interesting challenge and opportunity about how to make this happen, how to co-design all this trustworthy requirement and distributed or federated learning infrastructure. So again, this is actually another topic that requires a lot of interdisciplinary exploration. We need to bring together people from systems, from machine learning, from privacy and security. And these are just only two examples of challenges and opportunities around distributed learning today. And as a system community, I think it's fair to say that we need innovation at all levels of the whole system stack. So we need innovations about the machine learning model and technology to really understand how to do certain operations more efficiently or effectively, for example, pruning or quantization. We need to understand how to build machine learning frameworks and how to take advantage of latest advancement in operating system and network, for example, 5G, RDMA, so on and so forth. And also, how can we take advantage of co-design the hardware accelerators? Moving distributed learning as a field forward really requires us to have innovations in all these aspects. The goal of this workshop is really try to bring together researchers from different areas to really facilitate knowledge exchange around the topic of distributed machine learning. This is a continuation of the great success that we have last year in organizing the first edition of Distributed ML workshop, right? So this year we continue that. We have 20 technical programming committee reviewers, and we accepted 5 papers submitted to the workshop. In addition to that, we have 4 keynote speakers or invited talks, and also we have 1 amazing panel discussions. So it's going to be a very exciting program today. So now let me just walk through a little bit about the structure, and then we can get the technical content started. So the first session will be about distributed learning. The theme is really about how can we optimize the scaling, the performance, the speed of a distributed learning systems. We will have our keynote from Chunxiong from ByteDance and talk about how to systematically do communication acceleration for distributed DN training. And we have 1 presentation from 1 set of papers, and then followed by 1 invited talk from Max about how to do decentralized deep learning over weaker networks. And follow this, we have 2 sessions related to federated learning and security for machine learning. The second session about federated learning, we have our second keynote, Ginger from CMU, talk about fairness and robustness in federated learning, followed by the presentation from 2 accepted papers. And then we have another session, talk about federated learning with the third keynote from Mosharraf from University of Michigan, and followed by 2 presentations about security and machine learning. So after this, we have 1 fascinating panel session to really bring researchers together and discuss opportunities and challenges around distributed machine learning today. So if you look at the keyword of all of this, it's going to be an amazing day. We are going to cover things like performance optimization in both data center and weaker networks, how to do this on the edge, how to do federated learning, what is the security implication, how to do benchmarking and simulation. So really looking forward to go through a program together with all of you guys.